Law of signs, ambiguous case examples. So in a previous video, we talked about the different scenarios that can happen with the ambiguous case where you know two side lengths and an angle, and you know an angle and its opposite side. So it's a law of signs problem. We talked about those situations. So I want to go through an example of each of these. And here we go. With each problem, you are approaching them as if you don't know how many solutions there are. On these examples here, I have labeled what they end up being just for ease of looking back at your notes for those examples. Oh, come on, iPad, you can make it through this video. And then later on, I have some examples the way that you would see them, where it doesn't tell you how many to expect. All right. So for the no solution example, solve this triangle. The first thing I make note of when I do a problem like this, even though I know there's no solution here, I make note that I am starting with one acute angle. When you start with one angle, it's the ambiguous case. So start with one angle, which means it's ambiguous case. Right? And if the angle you start with is acute, that's when there's a possibility of two triangles. Angle is acute, so that's less than 90 degrees. Check for second triangle. You always make this note to yourself, put it on your paper when you do a problem like this. It should be the first thing you put down for the problem so that you remind yourself to come back to it. The reason, I should have mentioned this in the previous video, the reason that it being acute is important here, with the two triangle situation, it produces an acute angle and then an obtuse angle. There's one that's acute and one that's obtuse. And if you start with an obtuse angle, you can't have two obtuse angles in a triangle. So there's not going to be a two triangle situation for it if the angle you begin with is obtuse. Right, so the angle is acute. That's important there. So we'll say triangle one. We're trying this as if we think there's going to be two triangles. Triangle one. I look, I see that I have everything that I need to know about C. And I have half the information about A, which means I should be solving for A first, for angle A1 first, because I know half of it. So let's see here. Sine of angle A divided by baby A is equal to sine of angle B divided by, oh, not B, ha ha ha, C. We have C, angle C divided by baby C. And we'll say sine of angle A1 because there could be possibly other angles A1. All right. I would be multiplying this A up here, and then I'd be taking sine inverse. If you're curious about the math of this, in a previous video, boop, the law of sines theorem video, I do a bunch of this rearrangement. You can take a look at those videos. I'm not going to do too much of that math talk here. So you would get that angle A1 is equal to sine inverse of A sine C over angle C, right? You would multiply the A up, then take sine inverse on both sides to get rid of this sine. Plugging in those numbers, angle A1 is equal to sine inverse of 2 sine 50 degrees all over 1. If you plug this into your calculator, you should get a math error. Pay attention to what your calculator says here. My calculator says math error. Your calculator might say something different. We came up with a few in my class when we did these problems. Oh no, don't look. Oh, don't look. We came up with a few. We came up with a few different ones that people's different calculators came up with. So one person said domain error, another one said undefined, another one said error O2 calculation. So you pay attention to whatever it is that your calculator is saying, because that is the thing that you need to know. If you come up with a math error, that means it's an impossible triangle. So there's no solution. If you try to solve for the first thing and you get nothing, boom, you are done. That's it. No solution. All right. And then I can go boom, boom, done. One solution example. Oh man, my iPad is at 3% battery. Maybe I should charge it a bit. All right, she's plugged in. So solve the triangle. Angle A is 40, baby A is 3, baby B is 2. Um, Round all answers to the nearest tenth. I notice that I am starting with one angle and it's acute. One acute angle means we need to check for second triangle. So the thing about the ambiguous case is the only thing you really need to look out for, even though there are three situations that could happen, the only thing you need to be on the lookout for is this one. There is a possibility of it being a no solution, but you don't need to look for it. It will come to you. And if it's a one triangle situation, then you don't need to look for it. You'll find out it's one triangle. It's just making sure to check for two triangles when it's necessary. So one acute angle means we need to check for that second triangle. I'm going to say that we have two. I'm going to say triangle one. And I'm going to start with, let's see, we have everything about A. We have half the information on B, so we can solve for angle B1 to begin with. So sine of B1 divided by baby B is equal to, let's see, A. Sine of A divided by baby A. Rearrangement, just like we did in the last problem, angle B1 is equal to sine inverse of B sine A, all divided by baby A. So baby B is 2, angle A is 40 degrees, baby A is 3. When you plug this into your calculator, it should give you, is this, hold on. There we go, yes. I'm going to round this number to the nearest, to 4 decimal places. It should give you 25.3740 degrees when you round it to 4 decimal places. You might say, Professor Cook, the problem very specifically says to round it to 1 decimal place. And you're right. The answer will indeed be 25.4, which is that number rounded to the nearest tenth. However, when we go to find angle C, if we use this rounded number to find angle C, then C will be rounded. And if C is rounded, when we go to find side length C1, the error because of rounding could be enough that our answer is wrong. So for intermediate calculations, you'll use that 4 decimal places at least is a safe number. All right, so we have found the first angle. Now that we have two angles, we can solve for the third angle quite easily. So angle C1 is equal to 180 degrees minus the other two angles. So minus 40 degrees for angle A, minus, let's see, angle B. You'll get that angle C1 is 114.6260. We now have enough information to solve for side C1. By the way, you might get down to this point and say, can't I use Pythagorean theorem to solve for C1? And I want to remind you that Pythagorean theorem is only used in the cases of right triangles, of which this is not a right triangle. So let me see here. C. We're solving for side C1. So C1 over sine of C1 is equal to, you could use B, but you would need to use the unrounded number for B. I'm going to use A. Just use what you're given. When at all possible, use what you're given. So we'll use A divided by sine A. If you rearrange this, you're going to get, let's see, A will turn into 3. Sine of, because you would be multiplying sine of C1 up to this side up here. Sine of angle C1, which is this guy, duplicate. Divided by sine of angle A, which is 40 degrees. If you plug that into your calculator, it should give you 4.2. 4.2. I don't need more decimals than that because this triangle's done. Now, I have done triangle 1. I need to check for triangle 2. Triangle 2. All right. For triangle 2, the first thing that you do, the very, very first thing that you do, and maybe I'll make this orange, is you're going to solve the first angle you solved for here. You're going to do 180 minus that angle, and that will be the possible angle B2 is 180 degrees minus angle B1. So angle B2 is equal to 180 degrees minus this number over here. Angle B2 would be equal to 154.626, right? So I would say 154.6 degrees. Now, the astute student might right now say, that doesn't feel so good, Professor Cook. I don't feel good about that answer. I'm noticing that when I add these two numbers together, we're past 180 degrees. We're at 194.6, and that is more degrees than we have in a triangle, and you would be correct. However, let's keep going. Let's keep going one additional step here. Let's try to solve for this third angle. That's the easiest. That's the next thing we have to do. So angle C2, that's going to be 180 degrees minus the other two angles in the triangle. One of them is 40 degrees. The other one is this 154.6260. That number there. If you plug that into your calculator, you're going to get negative 14.6260. And you can't have negative angles, right? No negative angles. So there is no second triangle. Boom. So it's just that first solution. Oops, why did I put all these decimal points up here? Boom, this should be rounded. By the way, in a previous video, I talked about how the smallest angle should be opposite the smallest side, the largest angle should be opposite the largest side, and how you could do this by organizing it small, medium, large is how I like to think about it, small, medium, large. So like this is the smallest angle is B, the medium angle would be A, the large angle would be angle C1. If I just look at the numbers here, we have that B is the small, A is the medium, C is the large, and then we just make sure that they match up. So mediums, smalls, larges, yep. And then there was no answer there for that previous one. So just a little bit of a check. It's one way to catch a mistake easy. All right, 2 solution example. You are starting with one acute angle. That means you need to check for a second triangle, and I am lazy, so I'm going to just boop, copy this, duplicate, come on down here. One acute angle, check for a second triangle. All right, so we'll start with triangle 1. We know everything there is to know about C, and we know half of A. That means we're going to be solving for angle A1 first, right? That means sine of A1 divided by A is equal to sine of C is the letter we're using, C over C. The rearrangement of this, angle A1 is equal to sine inverse of baby A is 2, angle C, maybe I'll just write one more step just so you can see it. Why not? It's an online video. I can take my time here. This would be what it is before I plug my numbers in. Angle A1, sine inverse of baby A is 2, angle C is 25 degrees, baby C is 1. Plugging this into your calculator should result in 57.6973 degrees, of which your answer, of course, is 57.7 degrees, but you keep the 4 digits. Keep all 4 digits there. Next, we're going to solve for that missing angle. There's only one angle left. So angle B1 is going to be equal to 180 degrees minus the other 2 angles in this triangle. Maybe I'll move it down here so there's space. Minus 25 degrees minus this guy. So minus 57.6953. Use that full decimal number. You'll get that angle B1 is equal to 97.3027 degrees. 97.3 degrees. Finally, we're going to solve for side length B1. So B1 over sine of B1 is equal to, I'm going to use C because those numbers are not rounded. So C over sine of angle C. So B1 is going to be equal to, you'll be multiplying this guy on the other side. C itself is 1 sine of angle B. Use the full number here. The full number, the full four decimal places at least. All over sine of angle C, which is 25 degrees. If you plug this into your calculator, you'll get, after rounding, 2.3. It's a good time to do a small, medium, large check. I'm looking at the angles first. We have small, medium, large. Looking at the side lengths next. Small, medium, large. Yep, they all match. Okay, so now we're going to check for that second triangle. All right, so divide it off there. I guess I have so much space here, I didn't need to cram it all in there, but that's fine. Triangle 2. Before, when we did this, we were able to get the first angle, but the second angle became a problem. Here, we're going to have a different situation. So the first thing, to find possible angle A2, it's always 180 degrees minus the original angle A1. So, oops, let's do this in orange. So angle A2 is equal to 180 degrees minus 57.6973. You'll get that angle A2 is equal to 122.3027 degrees. And rounded to the nearest tenth, that would be 122.3 degrees. Let's see, what color? We already did green. Let's do purple too. Oops, too big of a pen. Two. Now that we have two angles, we need to find our third angle B2. So angle B2 is going to be 180 degrees minus the other two angles in there. So minus angle A2 minus angle C. Let's do C and then A2. C and then A2. So angle B2 is equal to 180 degrees minus C is 25 degrees. A2, use this long number here, 122.3027 degrees. This comes out to, angle B2 is 32.6973. So this comes out to an actual number, 32.697. Oh, we only need one decimal place here, 0.7. 32.7 degrees. Because that comes out to a positive number, that means that there are indeed two triangle solutions. We just need to solve for the one last side. So we'll go ahead and I'll just use black for the last side. So 3, we'll solve for B2. So B2 divided by sine of B2 is equal to, we'll use C divided by sine C. B2 is equal to, C is 25, or not 25, C is 1. C is 1, baby C, that is. Sine of B2, which is 32.6973 degrees, I'm using that full number. Make sure to keep 4 decimal places when you do these intermediate computations. All over sine of 25 degrees. If you plug that into your calculator, you should get 1.3. So there was a second triangle here. All right, so there's each of those cases. For the next examples, you're not going to know what they are until we start them. So those will be in the next video. All right, I'll see you then. Bye.